Going to kind of go real quickly through what we spent 20 minutes doing on whatever day that was.
Monday.
Monday. Solving quadratic equations. What did we say a quadratic equation was? What's the standard form of a quadratic equation? Ax squared plus bx plus c equals 0, right? A cannot be 0. That's the only restriction on this formula. That's exactly right. If A is 0, then we have a linear expression and not a quadratic expression. All right, so what were some of the characteristics or qualities or properties of quadratic equations that we mentioned? Two solutions. The graph is a parabola. So that parabola has a focus, a directrix, an axis of symmetry, a vertex. Lots of things that we could talk about. X-intercepts, Y-intercept, it opens up or down. You know, there's a lot of characteristics and things. And all of those values come straight from this formula. Okay? Every formula related to a parabola comes from these three values, A, B, and C. So a lot of things that we're looking at here. So that was one of the things that we had a look at. We're expecting two solutions. What were the methods for solving quadratics?
Factoring,
Factoring,
square root properties.
Taking square roots, completing the square, which we said we're only really going to use that because I want to show you how to use the completing the square method to solve the quadratic formula. Okay, so completing the square is not a method that you're going to want to use a lot. There are some problems where it's really easy to use it. It's easier than the quadratic formula. And we'll look at a few of those, and some of you will catch on to it, but most of you are going to choose to either use solving by factoring or solving using the quadratic formula. And that's okay because you can use the quadratic formula to do anything. Right? You can use the quadratic formula every time. It's just longer than factoring when it can be factored. All right, and we looked at a couple of examples, right? Zero product property is what we use, so each quadratic formula or each quadratic equation has to be set equal to 0 because we want to be able to set the factors equal to 0 and solve. So zero product property tells us that we need it to be equal to 0 before we factor it, so we can set each factor equal to 0. All right? Okay, so we've solved this one. We did this one, right? We got x squared plus 5x plus 6 equals x plus 3 times x plus 2. Okay, let me pause this and... Okay, so we solved this one and we found that x plus 2 times x plus 3 equals 0, which means x was equal to negative 2 or negative 3. I want to remind you that you can check the answers by plugging the values into the original equation and making sure that a true statement results. Now there's a lot of work there involved in doing this, and when you start getting fractional answers, it becomes a lot less practical to do this. The best thing to do is to check your work as you go, make sure your factorization is correct, and make sure that you have done everything correctly through the problem, because checking it can get a little cumbersome when you start having fractional answers. Okay? We did this one too, right? We did this one. This one factors as x minus 4 times x plus 3. And this is what I mean by checking as you go. Check your factorization carefully. You can do that mentally on the easier problems. Make sure that it multiplies back together right. If it does, then you can move forward and check and make sure that we set each factor equal to 0 and change the signs of the linear terms there and then go. All right? You don't have to check the answers. You can if you like. All right, next example. I think this one's new, right? 4x squared minus 3x minus 1 equals 0. It's already equal to 0, and that's important when we're factoring because we have to use the zero product property. So it has to be equal to 0 in order to do that. Now, this one's a little bit more difficult to factor, right? We're not going to spend a lot of time talking about methods of factoring here because we've already done that. Just kind of move through here. So some of you are using a little bit different methods. The 4x squared minus 3x minus 1 equals 0. What's the factorization here? 4x squared minus 3x minus 1. Got to be able to do this now. Anybody got it? It's pretty easy, +1 and -1, right? We know that much. So this one's kind of easy to just guess your way through it. We need a -3x. So how about -4x plus 1x? All right, that works, doesn't it? What does that give us? Are y'all here today? Am I in a room by myself today? Why are you confused, Miller?
I don't know. Where'd you get this +1 and -1 at?
Well, because that's the only two numbers you can multiply to get the -1.
I'm just confused.
Yeah, I'm just doing trial and error factoring, right? This is a little different than any of the methods that we've looked at, but we know that if it's going to be a quadratic factorization, then it's going to be the product of two linear terms. So we multiply that times that and get -4. What are the factors of -4 that add up to -3? That would be -4 and +1. And so we need these factors to be -4x and +1x. Okay, so then that gives us 4x plus 1 times x minus 1. Now some of you are still using circle, slide, divide factoring method. It's actually less risky in the context of solving equations than it is in the context of just factoring. So we got to go. What's going on? Yes.
Can you circle slide divide?
Yeah.
So you can circle slide divide if you want to. It won't be perfect, like it won't like.
Yeah. All right. So
I'm just making because like that's why I didn't know what was going on, and so I was like I thought we couldn't use circle slide divide.
no, you can use circle, slide, divide. It's just if you're just factoring, there's a lot of risks with circle, slide, divide. A lot of things you have to remember. You have to remember to reduce the fractions before you move the thing up. You have to remember to take out a GCF, or you lose a factor. So there's a lot of things that you have to do with circle, slide, divide and the risks disappear here. Yeah, y'all listen, please. I hear some talking. Please don't talk. 4x squared minus 3x minus 1. If we're just using circle, slide, divide, I want to show you what I mean by the risk goes away. If we were to multiply by 4 here, that gives us -4, right? The factors of -4, -4, and +1. So that would be x minus 4, x plus 1. And you have to divide by 4, right? So what a lot of people do is forget to simplify this and just move the 4 up. Well, that doesn't really matter in this instance because if you solve that, you still get +1 as your solution. Right? And you could take this right here as it is, and x equals -1/4 is the other solution. Okay, so our solutions come straight from those things after you divide it out. You do still have to remember to divide, but you don't have to remember to do some of the other things. Okay, so the factorization is 4x plus 1 times x minus 1, and that'll give us x equals -1/4 or x equals +1 as our two solutions. Right? Any questions there? So your factoring methods are, you're seniors in high school, so that you've got a lot of different factoring things that you've picked up. I see 3 or 4 different kind of little methods for factoring as I, kind of watch your work. But whatever you do, you just have to make sure it's factored correct. All right, next example. X squared plus 10 equals 7x. X squared plus 10 is 7x. What are we going to have to do for this one? We're going to have to subtract 7x or transpose 7x to the other side, right? We've got to get it equal to 0 because we cannot use the zero product property unless it's equal to 0. So we've got to subtract 7x from both sides. And when we do that, we get x squared minus 7x plus 10 equals 0. Right? Now, what is the factorization of x squared minus 7x plus 10? X minus 5 times x minus 2 is correct. All right? You can check that just to make sure it works. All right, x squared minus 2x minus 5x, the two middle terms there. And that gives you x squared minus 7x minus 10, so we can set each of these factors equal to 0. Add 5 to both sides, you get x equals 5. Add 2 to both sides, and you get x equals 2. Pretty easy to check these if you want to. You can plug this back into the original equation. What's 2 squared? 4. 4 plus 10 is 14, which is 7 times 2, right? So that one works. And the 5 squared is 25. 25 plus 10 is 35. 7 times 5 is 35. So you can check your answers and make sure that they work. All right? You can do that without going through the formal, thing. Solve this using factoring. X squared equals 9. Now, you guys have already had solving quadratics twice, Algebra 1 and Algebra 2. Would you have to factor this one to solve it? What could you do? You could use square roots, right? The square root property says if x squared equals b, then x equals plus or minus the square root of b. So the 2 square roots of 9 are going to be the solution to this problem. So plus or minus 3 would work. All right, but if we're going to show the factoring process, x squared minus 9 equals 0, set it equal to 0. Now, how do you factor 2 terms? This is the main purpose of what I wanted you to see in this. GCF, difference of squares, and then cubes. That's the 3 options for factoring 2 terms. And we will solve equations that involve GCF, difference of squares, and cubes, because I promised you guys at the beginning of the semester that we would learn how to solve the equations like this. X squared minus 1 equals x to the 6 minus 1 equals 0. How many zeros does this have? How many answers? 6. There's 6 answers to this equation. All right? It's the sixth roots of 1. I know that's a little bit odd to you at this point, but how many square roots does a number have? How many square roots did 9 have in this problem? 2 square roots, right? Every number has 2 square roots, 3 cube roots, 4 fourth roots, 5 fifth roots, and 6 sixth roots. We're going to learn how to find those 6 roots algebraically, and then when we take trig, I'll show you how to find the 6 sixth roots of a number using trigonometry. All right? So, but that's kind of where we're going with this. That's beyond where we are at this point. Factorization of x squared minus 9 is what? X plus 3 times x minus 3. X plus 3 times x minus 3 equals 0. You could check the factorization to make sure you got it factored correctly, and we do. The result of multiplying conjugates is a difference of squares. Then set each factor equal to 0. Solve, and we get x equals 3 or x equals negative 3. We already knew those were going to be the 2 solutions, right? All right, what about this one? X squared plus 5x equals 0. We're solving by factoring. So the steps for factoring 2 terms are GCF, difference of squares, and then cubes. Yeah, so we can take a GCF outright. It'll be x times x plus 5. And you can confirm that that multiplies together to give us x squared plus 5x. And then we'll have x equals 0 or x plus 5 equals 0, which means one of our solutions is already here. A lot of people get confused at this point. Well, what do I do with that? You don't do anything with it. That's one of your answers. X plus 5 equals 0 means x can be negative 5. So our two solutions are 0 or negative 5. All right? Now, before I give you your assignment, let's look at a few other ones. Try this one, and let's make the factoring a little bit more difficult. 2x squared plus 12 equals 11x. Solve by factoring. 2x squared plus 12 equals 11x. First thing we would do here is subtract 11x from both sides because we want it to be equal to 0, right? Then what? Find the factors of 24 that add up to be, and what are they? Negative 8 and negative 3. Okay. So this one is pretty easy to factor. 2x and x are our only choices for 2x squared. It's going to be lovely with all the chip bag crunching in the YouTube video. It's Brittany Gowdy, ladies and gentlemen. 2x and x are our only choices. So from those, we have to multiply here and get negative 8x minus 3x. Right? So that means we have to put negative 4 here, negative 3 here. That gives us negative 8x, negative 3x. Negative 3 times negative 4 is positive 12. So we're in great shape with our factorization. Okay? Now, we would set each factor equal to 0. 2x minus 3 equals 0 means x equals 3 halves. X minus 4 equals 0 means x equals 4. So 3 halves or 4 are the two solutions for our equation here. All right, one more. Is everybody okay with this one? The factorization is never going to be super difficult on these problems. If the factorization is really, really difficult, then what should you do? Use the quadratic formula, right? But when factoring is difficult, that means probably your numbers are large. That's going to make the quadratic formula a little bit more difficult. But we will incorporate some calculator usage when we are using the quadratic formula. Okay? So this next test will be calculator active. Quadratic formula needs it. All right? So let's have a look at last problem before I give you your assignment. 6x squared plus 8. No, minus 8 equals 13x. 6x squared minus 8 equals 13x. Now this one's a little bit more challenging to factor, right? It's 6x squared. We have to set it equal to 0, so subtract 13x. Minus 8 equals 0. So we're looking for the factors of negative 48 that add up to be negative 13. Negative 16 and 3. And this is it's the obscure factor pair. 16 times 3 is 48. This happens on the ACT a lot, the 16 and the 3 for 48. So negative 16 and positive 3 is what we're looking for out of our middle terms. So these two are factor pairs are going to have 16x plus 3x. And that tells you right away that you can't use 6x and x, right? Because I can't use 6x to multiply to get either of these terms. Alright, so I need to use 2x and 3x. Order doesn't matter. 2x times negative 8 will give me negative 16x. And then 3x times positive 1 will give me positive 3x. 1 times negative 8 is negative 8, so I'm in good shape. Alright, so 2x plus 1 times 3x minus 8. That means our two solutions are x equals negative 1/2, x equals positive 8 over 3. Now, this problem may be an example where if your factoring skills are a little bit weak, quadratic formula would be more advantageous. But if you're not careful, you have to use the quadratic formula for every problem. You're not going to have time to finish the test. You're just not. Because it's not as fast as solving using factoring. And we'll see that when we cover the quadratic formula in a few days. So negative 1/2 and 8/3. So factoring is a pretty easy method to solve, right? We can't always use factoring to solve quadratic equations because not all equations are going to factor. All right. I did this little exercise last period. Give me 3 random integers.
-5.
7, -5, 17. Will that factor?
Probably not.
No way, Jose. 3 more random numbers.
12.
12,
2.
2,
0.
6. That won't factor. The 0 would have helped us out, Charlie. All right, but if the point of the matter is, if we're to get equations that will factor, we have to really be intentional. If you're just picking random numbers, the chances of getting an equation that's going to factor are really slim. It just doesn't happen, you know. Give me one more. Random numbers. 13, 9, 78. Y'all are really getting 4. It's just not going to work, right? So if you're just picking numbers out of thin air, the chances, if we're choosing random A, B, and C values for our quadratic expression, you're just not going to get factorable expressions very often. Right? Most quadratics, and when we say the word most there's an infinite number on both sides of the coin, but most quadratic expressions will not factor. So we have to have other techniques that we use. So we're going to build those techniques through the next couple of days. Your homework is page 152, 1 through 14. You got 20 minutes to get a jump start on this.